All right, so today will be our last lesson on circles. We covered in the last lesson how to find angle measures when we have intersecting chords, secants, and tangents. Today we're going to look at how to find missing segment lengths, again with intersecting chords, secants, and tangents. All right, so let's start with intersecting chords. The rule says if two chords intersect in the interior of a circle, then the product being multiplication, the product of the length of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So here's a picture. We've got two intersecting chords. All right, they're intersecting inside the circle. Notice it is not the center. Although if it was, this rule still works, but these do not intersect at the center. But what happens when they do intersect is you create these four segments. We've got segment A and B of one chord and segment C and D of the other. So the rule says that the product of A and B, so A times B, will equal the product of the other two segments, C and D. Okay, so let's look at our two examples. So in number one, what I notice is I've got intersecting chords, again, inside the circle. So I've got X and 27. So 27 times X is going to equal, and then 9 times the 21. All right, so we've got 27X equals 189. Divide both sides by 27. And we've got 7. It only asked us to solve for X, so we're done. Number two, a little bit more algebra involved. All right, so we've got 3x plus 1. We're going to treat that as a quantity times 30. So we'll write number in front. So 30 times 3x plus 1 will equal, and then we've got 42 and then another quantity x plus 11. So again, we'll put the number in front and the quantity x plus 11 behind. Just distribute and go from there. So we're going to have 90x plus 30 on the left equals 42x plus 42 times 11 is 462. And then we'll get the x's on the same side. So I'll subtract 42x, bring it over here, and we get 48x's plus 30 equals the 462, and then subtract the 30. So we've got 48x equals 432. So if we divide 432 by 48, x will be 9. This one didn't want us to find x. It wants us to find the measure of segment US. US is the entire chord. So what we're going to do is we're going to substitute the 9 in for x and add the 30 to that. So 27 plus 1 plus 30. The measure of US is going to be 28 plus 30 is 58. Okay. All right. Intersecting secants. All right. Now notice intersecting secants, and secants go through your circle twice, are going to intersect outside the circle. Rule says if two secants share the same endpoint outside a circle, then the product of the length of one secant and the length of its external segment will equal the product of the length of the other secant segment and its external segment. In other words, so let's take a look. So we've got this secant segment, which together would be A plus B. And then we have another secant segment. Put those two parts together, we get C plus D. The rule says it's the whole segment, A plus B, times the external part. So I'm going to put that in front. All right. So A times the whole segment, A plus B, is going to equal the external part of this secant segment, which is C, times the whole secant, which is C plus D. So external times the whole thing equals external times the whole thing. So when I look at number 3, all right, I've got an external part of 7, and then I would need what would represent the whole secant segment. And x plus 7 is just that, x plus 7. And then I've got an external part of 8, and then I need the whole secant segment, which would be 8 plus 13, which is 21. So to set up my equation, I'm going to have the external part 7 times the whole secant, which is the quantity x plus 7, and that will equal 8 times the whole secant segment of 21. So we have to distribute on the left. We get 7x plus 49, and that will equal 168. Subtract the 49. So 7x equals, let's see, we get 9, 119, and then divide 119 by 7, and x is 17. That's all they wanted, was us to solve for x. So we're done. In number 4, again, you got to just notice these are secants and they intersect outside the circle. So the rule says we take the external part. So I'll start on the left this time. So I've got 10 is the external, and I need then the whole secant, which will be 10 plus 8, or 18. And then my other external part is 9. And then I need to add those together. So 9 plus 2x minus 7 will give me 2x plus 2 when I combine those. So to set up my equation, on the left I've got 10 times 18, and that will equal 9 times the 2x plus 2. And then we go from there. So 180 equals, we'll distribute on the right this time, so 18x plus 18. Subtract the 18 over, and we get 162 equals 18x. And then divide 162 by 18, and x will be 9. They didn't just want x for this, they want us to find the measure of segment MN. MN is just this interior part here, the 2x minus 7. So we'll substitute the 9 in for that. So 2 times 9 minus 7 is 18 minus 7. So the measure of MN will be 11. All right. And then the last one is when you have intersecting secants and tangents. All right, so if you look at our picture, we've got a secant that's going through our circle, hitting twice, and then the tangent, which touches in one place. This rule says if you have a secant and a tangent that share the same endpoint outside the circle, the product of the length of the secant and the length of its external part, like we did before, will equal the length of the tangent segment squared. So in other words, it's the external part, which is A, times the whole tangent, which is also A. All right? So we've got the external part B times the whole secant segment, which is B plus C. And that will equal the A squared. Again, it's kind of the same thing because A represents the external part and it represents the whole tangent. So it's like doing A times A. All right, so look at number 5. So down here, I've got my secant, the external part is 12, and the whole secant would be represented by 12 plus x, or x plus 12. And then here's my tangent, which is 18. So the rule says I take the external part of 12 times the whole secant, x plus 12, and that will equal the tangent squared. So we'll distribute, and we get 12x plus 144 equals 18 squared, which is 324. So we subtract the 144, and we get 180, and then divide 180 by 12, and we get 15. Solve for x, so we're done. All right, let's look at number 6. My secant, the external part is 18. When I put 18 and 14 together, we get 32. And then notice my tangent is 8x. So the rule says the external secant part times the whole thing, so 18 times 32, will equal the tangent, which is 8x squared. Now, folks, we can't just put the square like that, because then it looks like just the x's squared. You must put parentheses around the 8x and square both the number and the variable. All right, 18 times 32 on the left is 576. And then this will give me 64 for the 8 squared, and then x squared for the variable squared. So we're going to divide both sides by 64. And we will get 9 equals x squared, and then take the square root of both sides, and x will equal 3. And that is what they wanted, was just x. Okay. One more example. All right, so again, for the secant, the external part is 18. Put that together with 14, and we again get 32. And then our tangent is the quantity x plus 7. All right, so we've got external times the whole secant, so 18 times 32 is going to equal the quantity x plus 7 squared. So once again, we already know from up above that equals 576. And then when you square a quantity, you're going to write it twice and then factor it out. Now, I want to try something real quick because I'm going to show you 2 different ways. All right, so I'm going to finish it this way because this would be the long way, to be honest. So we've got 576 equals, this would give me x squared plus 7x plus another 7x plus 49 when I distributed all this out. So I would get x squared plus 14x plus 49. It's a quadratic, so we would set it equal to 0. And then your choice is to try to factor it or to use the quadratic formula. All right, so 49 minus 576 is minus 527. All right. Now again, we could try to factor this. So we would look for 2 numbers that multiply to be 527. And if I could, not sure I'm going to get it real quick. All right, so let's do the quadratic formula since I'm not getting it really fast. So I would do x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a, so 2 times 1. And then what this would give me is negative 14 plus or minus, and then type in everything underneath there. So 14 squared minus 4 times 1 times negative 527. And we get 2304 over 2, and the square root of that is 48. All right, so we've got negative 14 plus 48 over 2, and then negative 48 minus. All right, so our 2 options would be 17, and then negative 48 minus negative 31. And of course, the negative in this case doesn't make sense because it gives us a negative length. So x is 17. All right, so that really is kind of the long way to do it. All right, I'm going to go back to the beginning and show you another way. So let's go back here. And we would have 576 equals the quantity x plus 7 squared. And then you guys are going to say, why didn't you just show us this from the beginning? Because you don't always recognize and notice. All right, I know my brain obviously is in the multiply everything out, work with the quadratic. But when you get to this step, all right, as long as both things on both sides are squared or perfect squares, then we can just take the square root. All right, if this number over here is not, then this method doesn't work. All right, but when we do take the square root of 576, we get 24. All right, so I can take the square root of the left, and then I can take the square root of this because the squaring and square rooting cancel. So 24 would equal x plus 7. And then all I would need to do is subtract 7 to get 17 for x. And I know you guys are going, why didn't you just show us that way? Because it doesn't always work. It doesn't always work, all right? So you can certainly try it, but again, you've got to have a perfect square in order to keep going this way. If it's not, then you have to come back, multiply it out, and work through it using the quadratic formula. All right. Okay. So we've got those 3 new rules: intersecting chords, intersecting secants, and then intersecting secants and tangents. All right. Let me know if you need any help, but you can start your practice.